Hello everyone. How are you guys doing? Hi Case, Queenie, so I'm doing fine, alhamdulillah. How about you guys? Doing good? Hi Tom, and Mia. Oh indeed. How big can the cheat sheet be? Um, Usually I don't care how big the cheat sheet is, so you can make it as big as you want, but not to get into trouble with the department. Um, it should be normal paper size. But personally, I don't care. Okay. And it must be one-sided. Everything in one side. Yep. So you reminded me of the exam. So today is 9th. We are gonna finish chapter 8. Then next Monday we have no class. Next week, Wednesday, we are gonna do a review. And on the following Monday, October 21st, we are going to have our first exam. It will be in class during class time. It will be based on chapter 1 to 8, except 5. And I posted the review sheet on Blackboard. So you should study the review sheets material. Don't memorize things or don't just write down the stuff without understanding it. You're definitely not going to see the same question from the review sheet. There will be similar questions, similar scenario. So you should know how to solve something or what's the main concept behind every chapter I gave you on the review sheet. And the solution of the review sheet is inside our lecture videos. If you took notes in every class, then all you have to do is look at your notebook and you'll see the solution there. And if you did not take notes or you are absent, all you have to do is dig through all the lecture recordings and you'll find the solution. Okay? Any questions, comments, concern, anything? Nothing? Okay. Chapter 8. It talks about sampling distribution. And sampling distribution means we are observing many samples, and sample mean of the sampling distribution means from each sample we collect their mean, and then from all those means we collect the last mean. The last mean is the sample mean of the sampling distribution. So when you work with many samples drawn from the population, we call it sampling distribution. Just like we had binomial distribution, discrete random variable, or uniform distribution. The sampling distribution is another type of distribution where we work with, instead of one sample, we work with many samples. And when we collect the mean from all the means, that mean of the sampling distribution is actually very close to the mean of the population. So this is what this thing means. The mu of the x bar equals mu. Mu is a population mean. So the mean of the sampling distribution is same as mean of the population. And sigma of x bar it means the standard deviation of sample mean. It's not exactly the population mean. It's a population mean divided by square root of what is our sample size. So n is the sample size. On chapter 7, we learned that in order to convert any type of normal distribution into standard normal distribution, this is our formula we use. So we subtract the population mean from whatever we have, we divide it by population standard deviation. We get a z, and then we get the probability for the z score from the table, and that tells us the probability of whatever we are looking for. Now for sampling distribution, we use the same formula. The numerator is same, but on the denominator, instead of only the population standard deviation,
Okay, I have to go.
If I skipped today, I just probably would have been
I have
like.
to go. I'm waiting for this shit fucking
If
guy.
I skipped today, it probably would have been like my sixth.
Karina, question?
Are you guys gonna be here after 6:45?
Nah, it's symphony.
It's okay. I'll
Do
be
you have
here.
any question, Karina? No, probably it was just an accident. Okay, so what I was saying? Denominator. So on the denominator, instead of only dividing by sigma, we do sigma divided by square root of n, because that is the standard deviation for sampling distribution. So whatever we have, we always subtract the population mean from that, and we divide it by our standard deviation. If we are on normal setting, we divide it by population standard deviation. But if we are on sampling distribution setting, then we divide by the standard deviation for the sampling distribution. So that's the story behind our chapter 8. And now we apply all this knowledge to see in real life when actually we use this. So one of the example we studied in our last class, but we did not finish. So let's start from the beginning again. It is a random sample of size 64 is selected from a population. And that population has a mean 80 and standard deviation 10. What are the mean and standard deviation of the sampling distribution of the sample mean? So in one, we said sampling distribution of the sample mean is same as the population mean. So we don't need to do any math since you're already given population mean. So that is our answer for mean of the sampling distribution. For standard deviation of the sampling distribution of the sample mean, it's a long sentence, but that's how we read it, is population standard deviation divided by the square root of our sample size. In this case, they're already telling us that population standard deviation is 10, and we have 64 people in our sample. So square root of 64. That gives us 10 over 8, which was 1.25. We got that in our last class. Now they want us to do more. They want us to find out what's the approximate probability that X bar, which is sample mean, will be within 0.6 of the population mean. Okay, so we have sample mean and we have population mean. So they want us to figure out what is the probability that the sample mean will be 60% within the population mean. So if this is population mean, and let's say this is 0.6, they want us to find out what is the probability that our X bar will lie within this setting. So within, it means close to the mean. So we say, well, we want to figure out our x bar is within our 0.6 of population mean. So if this is 0.6 and this is also 0.6, obviously this side should be negative. So mu minus 0.6, that gives us a left portion, the left portion, and mu plus 0.6 will give us the right portion. They want us to figure out what is the probability that our x bar is lying in this area. See, I did not use any trick. All I did was I converted the sentence into mathematical notation. Within means in close to the mean. So it's plus minus distance from the mean. So mu minus 0.6 and mu plus 0.6. That is within the mean. Okay, now you're going to use this conversion factor because we have no idea how to find this probability. It's hard. But we are so smart, we know how to use the table for normal distribution. So our goal is to convert this information and this information into a z-score. So basically, we are looking for 80 minus 0.6 x bar and 80 plus 0.6. 0.6 minus 80 is 79. 79.4 x bar and 80.6. In other words, our goal is to figure out what is the probability that our x bar is lying between 79.4 and 80.6. Well, we have a problem because we don't know how to find this. So we go to Z and we tell Z, hey Z, help us to figure out what's the probability. So let's say this portion going to give us Z1. So we want Z1 to be less than x minus mu over sigma over square of n. And this portion is Z2 less than x minus mu over sigma over square root. I mean, we're basically finding the same thing, just the x is different. So this is x for this one, and this is x for this one. Maybe I should say x1 and x2. Well, it doesn't matter. So we get z is less than 79.4 minus mu is 80 divided by our sigma is 10 over square root of 64. Well, why wasting our energy? We already know this is 1.25, right? See here, sigma over square root of 2n, square root of n is 1.25. So instead of wasting our energy on writing these details, we can simply use that information. We have 80.6 minus 80 over 1.25. Oh, I forgot another z. Z1 here and Z2 here. And we are finding what is the probability that this is happening. Any questions so far? How many of you are lost already?
I am.
Tell me which part I can clarify for you.
Okay, so when it comes to part B, the probability of mean mu, is that just like part of an equation? The thing in red?
Uh, so they want us to find what's the probability that our x bar will be within 0.6, or in other words, 60% of the population mean. So if the population mean is in the middle, like here, we need to figure out what is the probability that our x bar is lying close to the mean in both directions, 0.6 units. I'm talking about this picture.
Okay.
This is what it means, within 0.6 of population mean. So in both directions, if you go 0.6 units, whatever area you get, what's the probability that your x bar is lying in that area? So this thing, we converted into an equation. We said, well, we want to figure out x bar is lying. It means on the left side, we have mu minus 0.6. And on the right, we have mu plus 0.6. If you look at the picture, you can see clearly this is what is happening. On the left side, let me change the color. We have mu minus 0.6. Because this unit is 0.6. Actually, this is kind of misleading. So this part here is mu minus 0.6. Because the distance from this to the left unit is 0.6. Same thing, the distance between the mu and our right end of the highlighted part is mu plus 0.6. Exactly in the middle, we have mu. On the left, we have the left end is mu minus 0.6. On the right, we have mu plus 0.6.
Got it. Thanks.
So we know mu is 80. So we found out what actually we are looking for. What are the two numbers we want our x bar be within? So you found that we want to find the probability that x bar is lying between 79.4 and 80.6, because our population mean is 80, and here we have 79.4, here we have 80.6. So first step we did was I found out these two numbers. So this is 80, this is 0.6, this is 0.6, this side is a minus, this side is a plus. So you want to see what is the probability that the x bar we are going to find, it will be between these two numbers, where we already know that our population mean is 80. So we have no idea how to find this probability. So we go get the z's help, because z has a nice formula. We can convert anything into z, and then we can find the probability using the z table. So the z formula we're supposed to use is this one. Z is less than x minus, it's less than because on the chart we have only area on the left side, which is less than. If you want, you can put equal sign, no problem here. Main idea is in the chart, the area is always less than of whatever z score you're gonna get. So we substituted everything into the z formula. Since we have two sides, like two numbers to work with, so we apply the z formula twice. And then we find the z score you're looking for. So let me not erase this and go to the next page. Oops. So probably, oh no. We want to find what's the probability that our z1 is less than. Did anybody find out what's the number on the left circle? How much is it? 79.4 minus 80 divided by 1.25. Great. Thank you. Negative 0.48. And on the right side, we have Z is less than Z2. 80.6 minus 80 over 1.25. Positive 0.48. So we want to see what's the probability that we have X bar is lying between these two Z-score. So we go to our table and find out what is the probability for, oh, never mind. Before we do that, we do one more thing. It's probability, this whole thing is same as probability Z2 is less than or equal to 0.48 minus probability Z1 is less than negative 0.48. Remember, to find the probability of the middle, we do bigger one minus smaller one. So bigger area minus smaller area. 0.48 is bigger than negative 0.48. So we take the area. Probability means area under the curve. So we take the area under the curve for the bigger number and we subtract. So this is bigger area. Bigger area under the curve and we subtract the smaller area under the curve. So let's see in the Z table, what do we get? Oh no. Negative 0.48. Sorry, negative 0.48. Yeah, 0.4. 0.4 is this line and 0.8 is second from the left. So second from the left, it means this one. Sorry, I can do twice. Can I use pen? Probably I can. No, it's just for sign. Never mind. It's 31.56.1. So 0.3156.1. Oh, this is negative, my bad, small area. 0.3156.1. And we need to find the bigger area. You know what? Let me just open with PDF. Then I can write on it. Okay, great. Positive 0.48. So positive 0.4 is this line and 8 is this line. So they're intersecting at 0.68439. So 0.68439. We have bigger area minus the smaller area. And we got 8783. Well, this doesn't make sense. So we can say, well, this is same as we have 36.9% probability that our X bar, it will lie here from between negative 7, no, not negative, positive 79.4 to 80.6. Because our mean is exactly in the middle, 80. So this is the population mean, and there is 37% chance that our X bar will lie within 79.4 to 80.6 within that area. Question? Any question, guys? Or anything out there?
Can you go over the part where you like the part you get 1.25, and can you explain that part and the rest, please?
1.25. 1.25. I was too lazy, so I didn't do the math because we already did that here. Do you notice that on the left side of the page, we have sigma of the X bar. Let me highlight it for you. Change the color to blue. See, sigma over square root of n is same as this one. So it's the formula we are going to use is 10 over square root of 64, which is 1.25. We already know it from here. So that's why I didn't do any math there. Instead, I just simply got the information.
Okay, I understand that part, but like when you was making the table, like how did you shift it from Z1 smaller or equal to the mean and smaller than Z2, and then you kind of shifted to like Z2 minus Z1.
It goes back to this thing. Oh no, I didn't teach you here. I didn't teach you chapter 7. So if you have a Z table and you want to find how much is the area we have between two Z value. So let's say this is Z1, this is Z2. Then the area between the two Z value is the area for the bigger one minus
I
the
get it now.
area
I
for the
get it.
smaller one.
Yeah, thank you. I get it. Thank you. Yeah.
So I use that knowledge here. We are looking for two areas. This is the bigger area, big, because our Z is bigger here. And this is the smaller area. So P means the area. It's a probability. Anytime you're finding the probability, it means you're finding the area under the curve. So probability of Z equals that number or less than that number is same as how much area we have under the curve for that Z value. Are you going to have a Z table in the exam? I'm going to give you the Z table. So you don't need to bring anything except for your cheat sheet, calculator, and pen or pencil. You don't even have to use scrap paper. If you need any, I'm going to give you that. Okay, would you like to try the next one? It's very similar, but not same. It's similar because you're finding the same thing, but this time you want to find its area from the mean. So not within the mean, it's area from the mean. So your formula is a little bit different than the formula I used in B. If you want to think about logically, think about the picture. This is our mean, 80. And let's say this much area is 2.1 on both sides. So obviously this is minus, this is plus. So this time you want to find out what's the probability that X bar will lie away 2.1 units away from the mean, not within the mean. So away means it's far. So we want to find out what's the probability that our X bar will be 2.1 point far from the mean? So you actually cannot have one equation like the way I combined everything. X bar is less than or equal this, bigger than or equal that. So for this one, we're not going to have one equation. We have to do it two separate equations. Are you guys trying it? Just try it. Struggle with it. We'll do it together. If you try it in class, trust me, when you do it in exam, at least you have some idea what to do or how to start any question, something like this one. And if you just watched for me to give you the answer, you might get you might forget them during exam. So what's the probability that we are 2.1 unit away from the mean? If someone like to give me the formulas, how can you represent this area? Probability what? And how can you represent the next area? Any volunteer? Does it work? Find out within, and then you'll see if it works. Yeah, it might work actually. I actually didn't try it because when I saw array, I automatically seen two sides of the curve. So you try, find your way, find the within, and then subtract from 1. And then we will try the other way, how we're supposed to do it. And if they match, wow, that's great. Okay. .1 is just like 0.6 in B. In B, we use 0.6 units, and here we are using 2.1 unit. Lila, your Z is too big. I think you forgot to divide by standard deviation. Remember, Z has to be within negative 3.99 to positive 3.99. So we want, what's the probability that X bar is on the left side, we get a smaller area, if I'm not wrong. Yeah. X bar is, so we want our X bar to be here. So X bar has to be smaller than 80 minus 2.1. No, 2.1 minus 80. 2.1 minus 80. Yeah. 80 minus 2.1 divided by 1.25. Because our formula is x minus, no, I forgot the formula. What's the formula? X minus mu. Okay. So our formula is x minus mu over sigma over square root of n. But sigma over square root of n is supposed to be one term. So 2.1 minus 80 divided by 1.25. That is what we have for the left portion. And for the right portion, we want our x bar to be bigger than 2.1 plus 80 over 1.25. Well, it doesn't matter because at the end the sign, we're gonna work with that later. So in between we get or. We want it's less than this or it's bigger than that. So if you do the math, it's probability x bar is less than which two numbers? Negative 77.9 or x is bigger than positive 'Wait. Sorry, my bad. I'm not supposed to do this here. That's why I was thinking, what's wrong with this? Here, I'm supposed to just add with the mean. So it's 80 minus 2.1. This is our lower bound. 80 minus 2.1. So I was thinking, why my sign is working weird? And this upper bound is 80 plus 2.1. So 80 minus 2.1 and 80 plus 2.1. So we get 77.9 and bigger than 82.1. Okay, so Lila, this is not Z, this is X. Now you're going to convert that into Z using the Z formula because we have no idea how to find this. So we write, well, this is same as probability that Z is less than 77.9 minus 80 over 1.25 because that's the formula we are using here and here. $82.1 minus 80 divided by 1.25. Are you guys lost? Okay, the next we find that Z is less than negative 1.68. Thank you for the number. Negative 1.68. Or this is same as probability Z is bigger than positive 1.68. But then you have a problem. We have no idea how much is this because on the thingy on the table, we don't have the bigger area. We have the less area. So we need to do math here. 1 minus probability Z is less than or less than equal, it doesn't matter. 0.68. This one is easy. We can get it directly from the table. Negative 1.68. Negative 1.6 is here, and 0.8 is here. So both of them, they intersect at 0.04648. 0.04648. And this one minus 1.68, positive 1.6 is here, and 8 is the last one. So 0.9535 0.9535. What is this? So this will give us 8464. Oh, same thing. You see, this and this, they're the same thing. Wow, I wasted all time. Okay, now the thing is, in math or in statistic, or means addition. So probability of this or probability of that. In other words, we are going to add the two probabilities. So we get 0.04648 plus 0.04648, 0.0930. In other words, there is only 9.3% probability that our x bar will be 2.1 unit away from the mean. So it will be within 0.6 units. It has higher probability, but for away it's only 9.3% chance. Not a high probability. Any question? No? Okay, I have good news and bad news. Good news, I'm not gonna ask this type of question in this exam. Bad news, probably in the final exam you'll see this, because previously in previous finals, our professor gave this in the final exam. So you may see this again in the final exam, but you'll be safe not to understand this for this exam. Okay? Any question, comments, concern? Okay, great. Wonderful. So far, so good. Now, what will be in the exam is this: the sampling distribution of the sample proportion. So all this time we worked with sample mean, so we used x bar. Now we are going to do very similar thing, but this time we are going to work with sample proportion. Sample proportion is the proportion of individuals in a sample sharing certain trait, and we denote by p hat. And population proportion is the individual proportion of individual we draw from a population that share a certain traits or trends, and we denote that information using small p or pi. Some book use p, some book use pi, but for me we are going to use p. the small p for population proportion, and the small p hat for sample proportion. Now, what proportion mean? Well, if 43% of people entering a store make a purchase before leaving, then the big P represent 0.43, because this 43% of the people entering the store. So there are many people that go to store. Now, observing all those people, 43% they make a purchase. So this 43% is based on all the people that go to store. So that's why this number 43% represents the population proportion. So it's small p. And proportion is proportional, it's always decimal. It's not more than 1 or less than 0. On the other hand, if you say, well, 200 people, you observe 200 people when they went to store, and you found out that among those 200 people, 78 people made a purchase. So you have a small sample, and with that sample, you observe a group. So when you draw a group from a sample, you get the proportion of a sample. So it's the group of our total sample size. So that is the sample proportion p hat. Is it clear what's the difference between sample proportion and population proportion, and how do you figure them out? Any question from anyone about this? No. Behavior of sample proportion. Sample proportion is a random variable. And to summarize the behavior, we look at 3 things: the center, the spread, and the shape. Center is the mean of the distribution. And just like the mean of the sample, mean of the sampling distribution is the mean of the population. Same thing, the mean of the p hat is same as the mean of the population, which is p. And spread means how spread out our sample sample size plays an important role in the spread of the distribution of sample proportion. There's a less spread of the larger samples and more spread of the smaller samples. So if you have a large number of people to work with, then you'll have a spread that is very low, a low spread. But if you work with a small number of people, then your spread will be big. I don't have space for that. So less people give us more spread, and more people give us less spread. That's because we have to divide by square root of n, and n is the sample size. So the bigger the denominator, the smaller the fraction is. So if you work with a big number, it becomes small. But if you work with a small number, the whole thing becomes a big number. So that's why they have an opposite relationship. The bigger the people, the less spread our distribution is. And the less people we have, the more spread our distribution is. And the shape of the distribution of the sample proportion should bulge in the middle and taper at the end. In other words, it has a normal curve. So in the middle, it's tighter. At the end, it's spread out. And which sample size is a normal model that is a good fit for sampling distribution of sample proportion? Like, how do you know that we are working with a good model to have a normal distribution? Well, the condition says if you multiply your P with your sample size, and if you get at least 10 people, and if you multiply sample size with 1 minus P, and you get at least 10 people, then you are fine. It fits a good model to be a normal distribution, to have a normal distribution. And now this is the list. Make sure you have it in your cheat sheet. So P hat is the sample proportion. How do you find it? It's a small group divided by your sample size. The mean of that P hat is same as the mean of the population proportion. It has another name, is the success rate. And standard deviation of the sample proportion, it has this formula. So previously, the mean of the sample distribution, so not mean, standard deviation of sample proportion, standard deviation of sample mean was population standard deviation divided by square root of n. But this time, the population, the mean of the population, what I'm saying, the standard deviation of the sample proportion is P1 minus P over n, and then take the square root. What is P? It's the population proportion or the success rate. So make sure you write down all the details. P, this P is same as this P, success rate. And then these two are two charts that compare the proportion for the sampling proportion, the sampling mean, and just population distribution. Okay, so one example from the homework. A news article estimated that only 4% of those ages 65 or older who prefer to watch news rather than to read or listen, they watch the news online. So people from the age group 65 and older, they observe all those people and they figured out that only 4% of those people, if they watch news instead of reading it, then instead of using TV to watch, they use online system to watch. Before even going further, my question is, what is this 4%? What does this 4% represent? Is it P or P hat? Which one? Make your guesses. Even if you're wrong, no problem. Just think about something. What do you think this 4% represents? Does this 4% represent the sample or a population? Okay, one vote for P hat. Any other guess? Okay. Since you want to stay silent, I'll let you be. Think about what information you have. People who have ages 65 and older. So how many people you have in this group? A small number or a big number? Which one? 65 and older. Do you have a small number of people in this group, or do you have a large number of people in this group? Think about real life. Good, it's a large. So if you're working with a large number, does it represent a sample or a population? Good. Now 4% represent what? Sample or population? Come on. 4% of all the people ages 65 and older. That percent is a proportion. They did not take 4% people out of that group. They observed that among all those people who are 65 or older, 4% use online news to watch. So we are working with proportion. We are not working with a size, sample size. Since you got this percent from a population, so this 4% represent a population proportion. Out of all the people, they are 65% older, 4% do something. So that percent is the proportion of the population, not proportion of sample. So our P is 4%, but we don't use percent. We use decimal. So it's 0.04. If we are working with a sample, they definitely would have given a size, like from 200 people, or from 10,000 people, or from 5,000 people. They would have given us a number for sample. Since they did not give us a sample number, they just told us we observed all the people 65 and older. That means whatever we got from that observation, that information represents the population, not the sample. Okay, now reading further, it is a random sample of 100 people. See, here it says a sample of 100 people will be selected from this population. And p hat, which represents the sample proportion, will be calculated. What are the mean and standard deviation for that sampling distribution of p hat? So they give us p, what percent we have from the population. They want us to figure out what is p hat. How much is a p hat? The mean of the sampling distribution. So not mean of the sampling proportion. So before we learned that the mean of the sampling distribution is the mean of the population. Same rule applies here. The mean of the sampling proportion is same as the mean of the population. And the mean of the population means whatever we got from our observation. Exactly. That would make our p hat, the mean of the p hat is 0.04. Next, they want us to find what is the standard deviation of the p hat. Well, we have a formula. Standard deviation of the p hat is p1 minus p divided by our sample size. Whatever result we get, we take the square root of the quantity. So we know our p is 0.04. So 1 minus p must be 0.96, right? 0.96. And we have in our sample 100 people. We take the square root of the quantity. How much again? 0.02. This is 0.96. 1 minus 1.4, 0.04. So mean of the sampling proportion is same as the population proportion. And standard deviation of the sampling proportion is this formula. Now they want us to find out which of these makes sense for our 100 people. It says the sampling distribution of the p-hat is approximately normal. Well, we don't know that yet, because in order to have a normal distribution, we have to fulfill two conditions. One of the condition is NP has to be less than 10, and the other condition is 1 and minus P also has to be less than 10. Yusuf, question?
Yes. Sorry, just to backtrack a little bit. Can you explain why the sample proportion is equal to the population proportion in this case?
I cannot explain why. I can explain how. So when you worked with X bar, remember I said we took many sample and we found their average, and then we took the average of the average, and then somehow that average, the end average, is same as the population average. So statistician, they also found out that if you work with sample proportion, you get the same result. If you look at many sample, from a sample, if you take many sample proportion and take their average, if you take many sample and take any amount, not any amount, any proportion of the same number of people, and then look at their proportion, it represents the same thing as if you look at the population and its proportion. Like the same concept. On the first part, we worked with the X bar, which is the average. In the second part, instead of talking about the average, we are working with proportion. Does it
Got
make
it.
sense?
And is that, and that's always true?
Always true.
Okay.
And then we have to figure out the proportion we are working with. Does it represent a normal distribution or not? Because we always want to have a normal distribution because it makes our life easier. We can convert any type of normal distribution to standard normal distribution, and we can use our table. That is our goal. So in order to have a normal distribution, we have to see two things. Is NP less than 10? So not less than, my bad, bigger than. NP has to be bigger than 10, right? No, not bigger than 10. I forgot the rule. Sorry, my bad. Bigger than, yeah, true, bigger than. If it's less, it doesn't make sense. So we want NP has to be bigger than 10, and also N1 minus B has to be bigger than 10. If these two conditions fulfilled, then we're going to have a normal distribution. So you have to check NP. Our N is 100. We took 100 people from all the people above 65 and older. So we have 100 people, and we found that 4% of that 100 people, they watch news online. So 0.04. That gives us what? 4% of 100, 4 people, right? 4% of 100 is 4 people? Yeah. So this is 4. And we also have to check what is 1 minus B. So 196. So 96% of 100 is 96. So this is bigger than 10, but this is not bigger than 10. Since this is not bigger than 10 NP, so it's not a normal distribution. Sorry, I should put that bar here. So it's not a normal distribution because this condition failed. In order to have a normal distribution, both conditions must satisfy. As a result, they want us to increase our sample size. Now, from 100 people, we are increasing our sample size to 400 people. What if we take 400 people and see if 400 people gives us a normal distribution or not? So do the same thing. We figure out what is NP for 400 people. So 400 people, we are taking 4%. I think it's 40, right? If 100 people gives us 4, then 400 people give us, oh, not 40, sorry, my bad. 4, 4, 4 for 16. Is it 16? I actually don't know. 16 or 40, which one makes sense? 16, my bad. How stupid I am. It should be 16. Because they have 4, 4, 4, 4 twice. I mean, 4 times. Okay, so now it's more than 10. So the first condition satisfied. And then N1 minus P. So 96% of 400. Obviously, it would be bigger than 10. So since both conditions satisfied, so for 400 people, we are going to have a normal distribution. Normal distribution for 400 people. And it says, well, also find the mean and standard deviation for that 400 people. No problem, we can do that. Let's do it on the next page. So mean of the sample proportion is mean of the population proportion, which is still the same, it's 4%, 0.04. The percentage we did not change. On the other hand, the sigma of the proportion, it's P1 minus P over N under the square root. So 0.04, 0.96, but this time the 100 becomes 400. What number we get this time? 0.01. Previously, what did we have? 0.02. For n equals 100, our sigma of p hat was 0.02. But now for n equals 400, our sigma of p hat is 0.01. So see, for more people, we get less standard deviation because we have more accurate results. So does the sample size affect mean and standard deviation? I'm going to ask this type of question as a multiple choice in the exam or fill in the blank. Okay. So obviously the mean doesn't change. Mean is same. But the standard deviation, it gets reduced. The more number we have in our sample, the less we get for standard deviation, the smaller standard deviation become. So n gets bigger, standard deviation for sample gets lower. If you get lower people, then the standard deviation gets higher. So they have inverse relationship. Question? Is the sampling distribution of p hat? So yes, because we found out that NP is bigger than or equal to 10, and N1 minus P is also bigger than 10. So as long as these two conditions satisfied, we do have a normal distribution. Normal distribution. Normal. Okay, question? Any question, comments, concern, anything?
Yeah, sure. I'm gonna be a little honest. I'm a little lost in terms of the satisfy. Can you explain the why we want to satisfy those conditions in the checklist?
Answering why, I don't think I can do that, because this is what statistician told us, that if you can satisfy these two, then you have a normal distribution. I can think logically why, but I actually don't know exactly
Yeah,
why.
yeah. Like not exactly why, but just like your reasoning for it.
So n is the size. Oops, my pen is not working. So n is the size of the sample. So P is the proportion you're working with. So if n times P, what do we get from n times P? Is the sample size times the proportion. In other words, the proportion of the sample size, right? The proportion of the sample size. If the proportion of the sample size is at least 10, so I don't know why they picked 10. Probably they tested many times and they found out that 10 is a good number. So they are saying, well, if the proportion of your size is at least 10, it means whatever people you have, whatever people you are choosing, let's say you have 40 people. So if you have 44 people out of 40 people, and if it's 4 out of 40 is at least 10, then it's a good number that 4 people you're working with will give you the result you want to get. If it's less than 10, then no, it doesn't make sense. Like, you're wasting your time. You're not going to get a good result out of your experiment. What do you think?
Okay, so it's just in the context of the question that it's like telling us
40 out of 1%, my bad, this way. It's like proportion of your size. What percent? Proportion is like percent. What percent of people you are taking out from your sample to observe? Do you have at least a decent amount of people they share the same trait, or it's less than what you need to do some experiment? For example, what I think is this. Let's say I want to see how effective, let's say, a brain increasing pill is. Okay. Did you ever hear about brain increasing pill? Like, actually, we do have some pills that if you read it, it helps retain information longer. I never took it, but I heard they exist. So let's say I gave pill to all of my students, 30 people in class. If I observe only 3 people that, oh, their brain increases, I mean, their retaining power increases, does it make sense that I can say, well, this pill really works? Does it make sense by observing only 3 people, we can
no.
say that? No, right? Because our samples, the 3 people out of 30 people is very less. It doesn't make sense. So the same concept goes here. The amount of people you have, you want to do experiment, the result, you want to get at least 10 people to have the same result. If you have at least 10 people, then it makes sense. Otherwise, no, the experiment you're doing, it doesn't have much value.
Got it. Okay.
Okay, so we are almost done with chapter 8. We are going to finish in our last class with 1 or 2 examples, and we are going to do a review. And then you will have a test. Okay? Have a good weekend, everyone. Enjoy your Monday's class on Tuesday. Be safe.
Professor,
Yep.
did we have a class last Monday? I mean, was it Monday or
Yeah,
yeah?
last Monday we had class. Last Wednesday, school was closed.
Wait, so I'm so confused. I thought we didn't have like class on Monday.
No, we did have a class Monday. We did not have a class on Wednesday.
Okay, so today is Monday. Wait, sorry. So this week
Last
Monday
week,
we had a class.
last week on, let me actually share the calendar. So last week Monday, we had class on. Oh no, last week we had class the full week. 7, 9. Oh no, last week. Yeah, last week on 9th, it was Monday, we had a class. So on 30th.
Okay,
And then
so
October
this Monday
2nd,
we
we
didn't
did not
have
have any
class,
class.
right?
Huh?
So this Monday we didn't have any class, right?
We did have a class. You're talking about this week, right?
Yeah.
Day before yesterday? We had a class on 7th, and today is 9th, we have a class.
Really?
Mm-hmm.
7. It was lecture 10?
Yep.
Oh, wow. Oh, I got so confused. I thought it's like
It's next
this.
Monday.
Okay,
Next Monday,
yeah.
you're not going to have any class.
Okay, that's
It's
what
on
I was like so
14th.
confused with, and I don't know, I didn't attend the class.
So next Monday, you're not going to go any class. But
Okay.
Tuesday, you're going to go all of your Monday classes. But
So
we are not going to have any
yeah,
class.
okay. Okay, and then Wednesday we have an online lecture, right?
Right.
Okay, that
So
makes sense.
Shian, we don't have a class on Monday or Tuesday. You're going to go to all of your Monday classes, but for our class, I'm giving you a day off.
Okay,
We're
and
not
then
going
we
to
have
have
an
a
exam
class
on
on Tuesday.
the 21st.
Our exam will be 21st.
Okay. And are we gonna get like a review sheet or?
I already posted the review sheet long ago on Blackboard.
Wait, I'm so sorry. I think I'm just confusing it with because I'm taking like 2 math classes and
If you go to Blackboard, you will see the review sheet is there. And
okay.
the solution of the review sheet is inside our lecture videos because all the questions there are from our lecture notes.
Okay, I didn't realize like it's posted.
Mm-hmm.
Okay, thank you so much.
And you're allowed to use a cheat sheet, one-sided cheat sheet during exam.
One side of cheat sheet. Okay.
Mhm.
Okay, sounds good. Thank you.
Okay. Have a
Professor.
good weekend. Yep.
Professor.
Huh?
For the test, are we only gonna get sampling distribution instead of population distribution?
Population distribution is based on, no, sample distribution is based on population distribution. What I said was instead of giving you the question which was confusing to everyone, like within, away, those things. So I'm not going to give that question in the exam, but I may ask the easy ones. What did you do? Like these two. What is the mean of the sampling
So
distribution?
just the mean and standard deviation, not like the more confusing parts, right?
So we have two concepts. One is the mean of the sampling distribution of sample mean, and another is the mean of the sampling proportion.
Proportion?
So proportion means we have a sample and we took some people out of that sample.
Okay. Isn't that basically sample though? Okay.
It is sample, but
It's
we
like a
took
sample
a
inside a sample.
sample in a sample. So sample in a sample is proportion.
Okay.
And sampling mean means sampling distribution of sample mean means we look at all the sample mean and it is the mean of the sample mean.
Okay.
So when it is the mean of the sample mean, it's the X bar. But when you took only a sample from a sample, then it's the proportion, sampling proportion.
All right, thank you. Have a good weekend.
Okay. Bye.
Bye.
I prefer